All right, so ready for another deep dive. Today, we're looking at some seriously cool research coming out of the University of Bristol.
Oh, yeah.
All about lunar robots and, well, how we might be mining moon dust before too long.
It's interesting.
It is. We'll be focusing on this article all about their cutting-edge moon dust collection technology. And, get this, we're going to learn about the new tech, Andy, how it could totally change how we explore space, forever, Pretty big stuff.
Big stuff.
Yeah. So basically, the University of Bristol team has developed this awesome new simulation technology, right? Oh. And it lets you control robots on the moon remotely, of course.
Oh, remotely. Got it.
Yeah. So they basically ran a test where they controlled a virtual robot in this simulation to collect a sample of moon dust.
Mm.
But here's the kicker. They were only looking at the simulation, not live camera feeds or anything like that.
Whoa, so no camera feeds.
Nope. Which is a huge deal because, signal delays and all that.
Yeah. Yeah, that makes sense.
Exactly.
Wow. Okay, so why is remote operations so important for these moon missions anyway? I mean, apart from the delay you mentioned.
Well, think about it. The moon's environment is, super harsh.
Right.
You've got extreme temperatures, radiation, all that fun stuff. Sending robots instead of humans is way safer,
Way safer.
Yeah, and this simulation just makes it that much easier and more effective.
Okay, so walk me through this virtual model a bit more.
So picture this, a super realistic virtual replica of the moon's surface. They've even modeled the feel of the moon dust and adjusted everything for the moon's gravity.
So you're telling me they can feel what it's like to scoop up moon dust?
Pretty much. They get this thing called haptic feedback.
Haptic feedback, what's that?
So it mimics the feeling of actually interacting with the moon's environment.
Wow.
And, moon dust is super weird. It's nothing like Earth dust. It's sticky and abrasive.
Yeah.
And in low gravity, it's even weirder. And get this simulation isn't just some training tool for astronauts.
Oh.
They're actually using it to really control these robots remotely.
Wow.
I know, right?
That's impressive. How accurate are we talking here?
Well, in their tests, it predicted the outcome of this moon dust scooping task with over 90% accuracy.
90%? That's pretty good.
Yeah. And, I was reading this quote from the lead author, Joe Luca, and he was saying this could totally revolutionize how we prepare for and run lunar missions.
I bet. So they can use it for training and for the actual mission, right?
Yeah, exactly. Pretty versatile, huh?
Pretty versatile.
Super cool stuff, right?
Super cool. So, okay, if we can use this simulation for collecting moon dust, what about other stuff? Could it be used for, extracting other resources on the moon, too?
That's what I'm talking about. Think of it building structures on the moon, running experiments. The possibilities, they're endless, really.
Endless. And think about it. This kind of stuff could actually impact, people back on Earth. Who knows? Maybe it'll even, open up things like space tourism one day, right?
Totally.
Wow.
And you know what else is cool? This simulation could make space exploration, more accessible.
More accessible. How?
I was reading in the article that said something about, it could really lower the bar for people who want to, build lunar robots. Instead of needing tons of money for materials and special facilities, you can test out your ideas virtually first.
That's amazing. So anyone, even students in small companies, could contribute to, space exploration.
Right.
That's really cool.
So, okay, everything sounds amazing so far, right?
Yeah, totally.
But there's always a catch, isn't there?
There's always a catch.
The article did mention that there are still, some challenges, things they need to work on.
Like what?
Well, they said they need to look into, how people respond to this whole system, especially with those pesky signal delays we talked about.
Oh, yeah, the delays.
Imagine controlling a robot, but you have to wait 3 seconds to see what happens.
Yeah, 3 seconds. I can see that being a problem.
Yeah, it's tricky stuff.
It is. So even with this great tech, we can't forget about us, the human element.
Exactly. We're not just talking about code and robots here.
Right.
We're talking about real people controlling these things, making decisions millions of miles away.
It's a lot of pressure.
It is.
Yeah, it really makes you think, about the connection between, technology and our own psychology.
Totally. We're kind of having to relearn how to interact with the world, but, through this tech lens.
That's a good way to put it.
And speaking of interacting, we've been talking about how this simulation could be used for all sorts of things on the moon, right?
Right.
But let's get specific.
Okay.
Like resource extraction, for example.
Yeah, yeah.
You mentioned earlier that moon dust could actually be a source of valuable resources.
Exactly. Like water.
Okay, so break that down for me.
So lunar regolith, that's just the fancy term for moon dust.
Okay.
It actually has like trapped oxygen and water molecules inside.
Oh, way.
Yeah.
Yeah.
And if we can figure out, how to get them out, it could be, completely revolutionary for having, people living on the moon long term.
Okay, so I'm picturing like a moon base, right? Or even a colony, and they're getting their water just straight from the moon.
Exactly. That's wild. It's not science fiction anymore. People are already working on ways to extract these resources, know?
Like how?
Well, one way is to heat up the regolith, like really hot, so it releases the oxygen and water trapped inside.
Like baking it out or something?
Kinda, yeah, but on a massive scale, of course.
And there are other ways, too.
Yeah, some people are looking at chemical processes to separate out the stuff we need.
Like a giant chemistry experiment, but on the moon?
Huh. Yeah, something like that. And of course, the simulation, it would be super important for this,
Why is that?
Because it lets us, fine-tune the whole process to, get as much of the resources as possible without wasting anything.
Smart. And what about building stuff? Like, I remember reading that this simulation could be used to actually build lunar habitats.
Oh, absolutely.
Even like research facilities, maybe launch pads for, missions to go even further out into space.
Yeah, the possibilities are, incredible. And think about it. If you can test out how to build something in the simulation first, before actually sending anything to the moon,
you're way less likely to run into problems.
Exactly. It just makes the whole thing, safer and cheaper,
It's almost like we're like 3D printing buildings on the moon.
Well, not exactly 3D printing, but yeah, the idea is similar.
You design everything virtually.
Right. And then basically send the blueprints to the robots on the moon to actually build it.
Wow. Knowing that it's already been tested, that would be huge.
Absolutely. It just increases the chances of success.
I got to admit, I'm getting pretty excited thinking about all this.
It's exciting stuff. Building a base, getting resources, going further into space. It's like a whole new era.
It is. But before we get too carried away, there's something we haven't talked about yet.
Oh, what's that?
We've been talking about the tech, right? And like all the amazing stuff we could do on the moon.
Right.
But I don't know, something's been bugging me.
What is it?
It's like we're missing like a piece of the puzzle.
Yeah.
I
think I see what you mean. We talk about like what we can do with this technology, all the cool stuff we can build and achieve.
Yeah.
But we kind of forget about the who,
Exactly. Like we get so focused on the tech, we forget about, the people involved.
The human element.
Yeah. At the end of the day, it's people who are, making the decisions, taking the risks.
Right.
And, feeling the impact of all these changes.
And as we, keep pushing further into space, that human element, it just becomes more and more important.
I bet. Imagine like sitting at a control panel here on Earth, but you're controlling a robot that's all the way on the moon.
Yeah.
There's that time delay.
Right.
And I don't know, you're millions of miles away, and any little mistake could have like huge consequences.
Absolutely.
That's got to be like a lot of pressure.
It's a different kind of challenge, that's for sure.
Totally different from like the old image of astronauts planting a flag on the moon. Right?
Yeah, exactly. This is a new kind of frontier.
It is.
And it needs, a whole different set of skills.
Yeah. We have to like figure out how to support these people,
Exactly.
Make sure they can handle the mental and emotional side of things.
It's a good reminder that, even with all this amazing technology, we can't forget about the people behind it.
Totally. And what happens when, the robots get even smarter, like when they start making their own decisions?
Oh, you're talking about autonomous systems. That's a big one.
It is.
Because then it's like, okay, if the robot messes up, whose fault is it,
Right. Is it the person controlling it? The person who programmed it? It gets complicated.
It does. We've got to start thinking about all this now.
Yeah, before it's like Kool-Aid.
Before we lose sight of, the human element.
So anyone listening, keep asking those tough questions. It's not just about what we can do on the moon.
Right.
It's about what we should do.
What kind of future do we want in space,
Exactly. And how do we make sure everyone benefits from it?
Big questions.
Well, that about wraps up our deep dive on lunar robots and moon dust mining.
It's been fascinating.
It has. We've covered like the tech, but also the human side of things and the ethical questions too.
All important.
And on that note, we'll leave you with this thought.
Okay.
As we go further into space, what values should guide us? You know, what kind of mark we're going to leave on the moon and Mars and everywhere else we go.
Something to think about.
We hope this deep dive has given you, some things to ponder.
It certainly has for me.
Thanks for listening.